Hello everyone, welcome back to lecture 8 in a microcontroller course. So in the last class, in the last lecture, we discussed about some logical instructions and some branching instructions. So few branching instructions we left in the class, in the last class. So those are byte level jump instructions. So byte level jump instruction, that is compare jump if not equal with the destination operand and source operand. If these two, destination operand and source operand, will be compared, if both are not equal, then the execution control will jumps to the relative address specified in the instruction. Compare the two operand, destination and source operand. If the condition is true, that means if the two operand is not equal, then the jump will occur and it will jumps to the relative address mentioned in the instruction. Similarly, jump 0, jz is nothing but jump 0 if the content of accumulator, if the accumulator content is 0, then the jump will occur to the relative address, given relative address, that is program counter get incremented, and if the accumulator content is 0, then the program counter will added with the relative address and it will jump to the given relative address. Similarly, jump if not 0 to the relative address, jump if not 0 to the relative address if the accumulator content is not as 0, then the jump will occur and that jump will go to the relative address. Same as like jump 0 condition. Here the condition is accumulator is not equal to 0. So next byte level instruction, DJNZ, that is decrement jump if not 0. Here one more operand we need to insert to the above condition. That is one operand we are specifying here. That is, if the accumulator content is not equal to 0, then this operand will get decremented. That means if the condition is nothing but if the accumulator content is not equal to 0, one decrement will be happen to one operand. After that it will jump to the relative address. If the operand will get decremented, after that it will go to the relative address and program counter is loaded with that relative address only. So up to this we discussed about conditional jumps, and few unconditional jumps are there. There is no conditions, it will jumps to a certain location. Either it may be a part of this main program or the part of another subroutine programs, and that is called a unconditional jump. So unconditional jump, few types are there: AJMP, LJMP, SJMP, and normal jump, that is indexed addressing mode type of jump. So in AJMP we already know that the ranges, absolute range and long range and short ranges we are discussed in the last lecture. So based on that the jump will occur. So in AJMP, here the short address we need to give. So that address has the page address, we call it as a page address, so that will be within the main program, therefore we may call it as a page address. And that jump will occur in between 2 KB of address memory locations. So program counter is loaded and the program counter will jump to directly to the mentioned address. The address must be within 2 KB of memory location. Similarly, LJMP, that is long jump with the long addresses. Here also same, we need to mention the long address and the program counter will increment it and it will be added with the long address, that is 16-bit address. So that 16-bit address might becomes in the range of 16 KB of memory location. Within 1664 within 64 KB of memory location, it's not 6, it's 64 KB. So in between 64 KB it may occur long jump. And SJMP, this is a short jump. In order to terminate the program, sometimes we may use this SJMP. That will go to the 16-bit address. It is also relative address also you may call it as, because it's range within the main program and program counters limitation. Relative address of the program counter, that is minus 128 plus 127. It's not 27, it's 128 plus 127 location. That is, once the program will updated, the program counter will added with the relative address and it will load it to the program counter. And normal jump, in case of assessing the code memory, sometimes we use this instruction, that is jump at A plus DPTR. That means the physical address exists in DPTR and some memory location pointed by accumulator. Therefore, by adding these two, you will get certain physical address of the code ROM, and the program counter will get updated to that particular jump location. So in order to assess the ROM using the jump, we are using this unconditional jump. So next sub part of the main program, that is call and subroutine program. So call is the only one instruction which is used to handle the interrupt. So subroutine is nothing but some small part of the program. So this subroutine will be executed during an interrupt process. That means some disturbance will occur to the main program, so that disturbance requires some services, that is called as a subroutine. So there are, in order to enable the software interrupt, we are using this call instruction. So call instructions, it may take over the control of CPU. Either it may be in the main program or it will jump to the another part of the main program. That is called as a call instruction. Or else any IO devices can be accessed through this call instruction, or memory devices also access this call instructions. So in order to access that call instruction, the syntax is like this: call address. You need to mention the address of the call. Sometimes IO devices have certain fixed locations, so that locations use it to execute this subroutine. So you need to mention that address, calls address. So here also the two types of calls are there: absolute call and long call. Absolute call, you know that absolute range L with a long range. So absolute call has the capability to handle the 2 byte of instruction. This is a 2-byte instruction and it's 3-byte instruction, and the target address within 2 KB of range, and the target address may be 64 KB of range. And here is a syntax. Here is a process of a call instruction. That means the program counter will get updated and stack pointer content will be incremented, and the program counter lower order byte will be transferred to the stack pointer content. So after that, the stack pointer will get incremented again, and program counter higher byte will be loaded to the stack pointer. And after that, the program counter, the page address will be loaded to the program counter. Same process for lcall also. That means it is 3-byte instruction, stack pointer updated, and 8-bit of lower order 8-bit will be transferred to stack pointer, and stack pointer will get incremented. Higher order byte will be loaded to the stack pointer. Then program counter is loaded with the long range addresses. So this is about the process of branching instructions in 8051 in order to by using 8051. So for this we discussed all the instruction set in 8051, that is all last 5 types of instruction sets. So we need to study some comparison work in 805, and that is in most of the semester exams they are asking this question, and that is what is the difference between jump and call instruction, because both are uh, very crucial, plays a very crucial role in 8051 programming. Therefore we are going to discuss a small comparison work of jump and call instructions. That is, a jump is a program control which is transferred to the memory location within the main program. We know that at a conditional and unconditional jumps, those jumps is related to only a main program. There is no subroutine. Therefore, program control transfer to memory location within the main program. And in call instruction, the program control transfer to the memory location even outside the program, because subroutine is not only related to internal main memory, therefore it is also related to external memory. Therefore, it will jumps to some other part of the main program also. So immediate addressing mode, it uses only an immediate addressing mode. Immediate and register indirect mode, addressing mode is used in call instruction, because in order to fetch the code ROM or any subroutine, we are using register indirect mode. And initialization of stack pointer is not mandatory, because stack pointer here we are not using regularly, therefore no need to initialize the stack pointer. Here stack pointer is necessary to transfer the content of program control to stack pointer, therefore it is initialization is mandatory. Program counter is not transferred to the stack. The program counter value is transferred to the stack. As I told in the same reason third, here the program counter is doesn't performing any subroutine program, therefore no need to transfer the control to the stack. Here in order to handle subroutine, it need to transfer the control to stack pointer. And a return instruction is not necessary in a 8051 jump instruction, because it will directly jump to the given location, but call will jump to the another part of the main program, therefore return instruction is mandatory. And 10 t states are enough to perform this operation, but it requires 18 t states to complete process. And value of stack pointer does not changes. Here the stack pointer values may changes from each program to program. 3 machine cycle enough to complete the execution, but it requires 2 more extra machine cycle to complete the execution. So for this we have completed the instruction sets of 8051.